Hey everybody, welcome to Unit 2.14, Moving in Circles, aka the end of Season 2 of Physics with Arif, because it's the end of Unit 2, it's the light at the end of the tunnel, I can see it, I can feel it. Oh, finally. Anyways, so today we're going to talk about centripetal force. Centripetal force is the force to keep something spinning in a circle. For example, a string keeping a ball rotating around a person. If the centripetal force disappears, then the ball would fly in a straight line in the direction which it was traveling at the time. The direction is called a tangent, I think. So, yeah. As you can see, this is the string. It's the axis, it's the middle part, the orbit is where it goes. The centripetal force is not the force rotating it around, it's the force keeping it rotating around. See? Without the force, it'll just go right there. But anyways, so more. More centripetal force is needed if the mass of the ball is increased, if the speed is increased, or if the radius is reduced, aka the orbit. So if the orbit is smaller, then the velocity, the centripetal force needed is more. So you need a stronger string, you need a stronger centripetal force, or anything like that. Yeah, another example would be, I don't know, those Olympic medalists who use an iron ball and they rotate it around themselves? Well, that uses a chain because the radius of the orbit is actually very little, and they spin very fast as well, and also the object is very heavy, so that's why they need to use chains so that the chains could withstand the centripetal force and not break apart. Alright, change in velocity. If you repeat the experiment and we rotate the ball with a steady speed, you would think that the velocity will stay the same. But it does not. Why? It's because velocity is a vector quantity. The speed might stay the same, but the direction is always changing. So as you can see, velocity is facing right there, but when it's over here, it's going to face over there. So the direction change, but the speed is always the same. So if you say that what's the speed of the ball, you can always just say the speed of the ball is blank. But if they say the velocity of the ball, it gets a little bit more complicated because it's moving all around and you can't quite see. Anyway, let's talk about centrifugal force. This is the opposite of centripetal force. When you spin a ball around, you feel a tug on your hand. This is centrifugal force. There is no centrifugal force on the ball, however, because the ball does not fly outwards. It flies in the direction it was moving in. So as you can see, it's a car. It's moving around. The car feels a tug going there. But centripetal force is a tug going here. It's a little strange. It's quite hard to get, and I don't know, I don't really understand it fully either, but what can you do? Alright, orbits. Satellites orbit around Earth. How? There isn't a string to keep them in place, and yet they don't fly into space. This is because of gravity. Gravity is a sort of chain if you think about it. It keeps you on the ground, so you don't just fly off into space. But as you get farther away from Earth, the effects of gravity lessens and it becomes a sort of string. That's why a satellite can rotate around Earth, because of gravity. And gravity is the centripetal force of the satellite. Alright, next. Atoms also have centripetal force. The electron traveling around the nucleus has to have some sort of force keeping it moving in a circle, right? What is it? Again, the answer is gravity. I mean, kind of. As we discussed before, everything is attracted to everything. And so, so is an electron to a nucleus. The attraction itself is the centripetal force, as you can see. It gets attracted, it keeps rotating this way because it's attracted. That's how atoms work, and that's how nucleuses work as well. Alright. Finally, that's the end of season 2. It's 5 minutes each, except for a few exceptions. Thank you. Goodbye.